Yes.
All right. Okay. So the meeting is on. So first of all, I'll just be doing a really short sort of demonstration on DDPG, how things wrapped up. And I have to say,
Okay.
there's a minor issues with it that I haven't had the time to look into detail. Well, I try to look into detail, but it's kind of hard to debug.
The
So,
DD,
beg your pardon?
the DDPG.
Yes, DDPG.
Okay, let's.
Yeah, so I ran the comprehensive benchmark on the DDPG on multiple environments. The problem is the speed. It takes too long to run for some reason. And initially, I thought it was because the TensorBoard logging that was taking the significant amount of time. But then something weird happens. So I'll show you what I mean. So initially, let's see if I can find it. Where is the DDPG? It's here. Right. So initially, when we have the TD loss, right, over here, what initially
Yes.
we do is to just log the TD loss at this particular time step. So that means for each optimization step during the episode, we would log the TD loss using the TensorBoard. And according to the line profiling, program profiling that I've done, that's actually slowing down the program a lot. So if you see the screenshot of, did I share my screen?
Yes, I seen it
Okay.
in the Slack channel before. It takes quite some time.
Yes, 70% of the time was spent on doing this TD login. And it differs by machines. Some machines they don't take a lot of time. I think it's especially the weight and biases integrations that's slowing everything down as well. Without the weight and bias integration, the writer.s scaler doesn't add any overhead. But because so my intuition is that weight and biases they don't just upload the data every 1 second. Instead, what they would do is every time you call the writer.ask scaler, it issues the HTTP request. So a lot of the time, the program is actually just waiting for the socket to finish the
Uh,
transmission of the data.
Actually, in their documentation, they say they do it in an asynchronous way. So
Oh,
they
really?
just write it to a file, and there is another process that is taking that is syncing the data with the server. So I do not think it
Okay.
adds that much
Okay.
over. It's probably just the fact of maybe do you print some? You do not print anything.
I don't. Not really. Well,
In the
printing anything wouldn't change anything either.
mm. Usually I just log the last loss at the last time step. So
Right. Yeah. Right now, my implementation is to log the average. So if you look at the latest part of the code, what I do is to store the Q losses in the TD losses array, and then I
and then
sort of getting the mean of it,
okay, sure.
which makes sense. However, I'll show you what the result is actually happening when we look it up the benchmark. So
Oh, by the
for
way, the TG loss, is it the loss of the value function? Yes,
yes,
the Q
yes,
function. Okay.
it's a Q function loss, the temporal difference. So interestingly, you need to look at the system utilization. So this one is actually not that bad. So also notice how the CPUs is always not fully utilized.
Okay.
Um, so that's kind of a concern because we're kind of wasting money, I guess. But in some other environments, I've seen more drastic utilization slow down. Did you see this big drop?
Yes.
It's like after
And weird.
Yeah, it's like after 2 hours, the speed just kind of drops significantly, and I don't really know why.
Can you plot both the CPU utilization and the reward. Maybe if the agent starts doing longer rollouts, it,
That shouldn't happen because with our current implementation, we sort of run it in a batch size sort of manner. So the so
that is good.
in other words, the agent always have the fixed number of episodes to run, and it doesn't explain the drastic drop. You know, it's like something stopped here. You know,
Yes, this is indeed bothersome.
right? Yeah, and it's kind of I'm not so sure how to debug from here, and this was the problem with DQN as well. Basically, any problem with the sort of temporal difference approach. So let
Mhm.
me take a look real quick. So that would be weighted bias. That will be in any experiments that I ran quite a long time ago, and I want to see if I can find it. So this should be in the cleaner out folder, and it should be the pawn. If I look it up the system, okay, with the DQN, it isn't so bad, but it's also the case that the CPU isn't fully utilized. Oh, right, because this is actually trained by using GPU. If I only train it using the CPU, then it's going to be very
Taking
slow.
long. Yes.
So let me try to look it up a different one. Uh, so, for example, SAC would be another example that is usually very slow, right? So, for example, Pendulum, it uses 10 hours to run, but that's not
That
really.
is quite.
Yeah, let me see. SAC. Right. So, for example, DQN for the lunar lander would be another example, right? Here it's running for 1 million time steps, maybe.
Mhm.
Yeah, but you see that the SAC it uses 3 hours to finish, and usually PPOs and A2C they use within an hour, but the DQN uses 2 days to finish. And I'm interested. Yeah, it's a similar thing. It's like I don't know what's going on. It's like you have this decrease of CPU usage over time.
Mm. Did you run it on the same machine?
So this one was run on a big server, so it doesn't have the what's it called? It doesn't have the GPUs available, but all of the other experiments ran are without the GPU as well.
Okay.
Yeah, it is. Yeah, I would say it's definitely one of the weirder phenomenon, and I don't have a good explanation for what it is.
The CPU utilization graph, is it the overall CPU or?
Yeah, right. Overall, I think, and also, yeah. Let me look at something real quick. So, for example, this is A2C, right? It finishes within an hour, and I would be very interested in seeing its CPU utilization. So, it stays at about 30%, and eventually it drops. But this is 10%. I want to see the number of networks sent. Maybe it's a packet. So this is at the magnitude of 95 million for the DQN, right? Sorry, this is A2C. And with the DQN, see the difference? The
That
That's one, two, three. That's 4 trillions.
so
So
there's way more packets sent.
yeah, so maybe that is the issue. And what am I logging? It's really just the TD losses, right?
No policy loss, by the way. Ah, okay. Let me check how much DDPG takes for me.
Yeah, please do. But also, this shouldn't happen. Okay, let me now check the DDPG again and compare it with see if similar things would happen. So if I compare DDPG and PPO and inspect their packet sent, so this is PPO.
I think in my best case scenario for DDPG uses about 4 hours.
Okay, right, that makes sense, right? So let me take a look. So for the DDPG, it sends about 600 million. And in comparison, the PPO sends 166 million.
Oh, oh,
Okay, let's compare. Let's compare code for a second. Could you send me the file of your DDPG or give me a link?
sure.
And are you running with GPU or without GPUs?
Probably with GPU.
Okay, that also could change things very drastically. So if I run experiments with GPU, then it becomes a lot faster for some reason.
Uh, so many details to take into account.
Yeah, that's a really weird thing. So let me show you. So if I believe these experiments are ran with some of them. So for example, this walker, right? This walker takes 5 days, 21 hours to finish. And this walker
Eesh.
takes 12 hours to finish. You see that? This is without the GPU, and this is with the GPU, I think. Yeah, GPU, memory allocated, stuff like that. And the CPU is always very well utilized.
That
And
is DDPG on GPU.
this is DDPG on the GPU.
GPU, okay.
So as you can see on the GPU, the CPU even is very well utilized, and the CPU is right. CPU DDPG2 only using CPU on the other hand is not very well utilized for some reasons.
I
And
guess it's computation.
the network sent. This is again before the TD loss optimization. This is 5 trillion, and in comparison, $12 trillion. 5 trillion. Yeah, it's really confusing as to the reason why this is happening.
Okay, I sent the file in Slack.
Okay, unclean. Okay, that's pretty funny. I would expect it to be sort of similar. There shouldn't be a significant difference.
Oh, there's gonna be a lot of difference.
Yeah, but we know the parser things doesn't really matter. These things shouldn't matter. Which one is yours?
On the right.
Right, right. Okay. Oh yeah, I don't know about that. It is quite a lot of difference.
Let's maybe focus on the loss computation. it should be the same.
Yeah.
But the part don't match. Uh,
Okay, you know what? I'm just gonna go read your code directly. See if that helps. Oh, not again. Let's see.
I think the most important part should be around line. That's so nice.
Okay.
Line 433, something like that.
Right. After the episode is finished.
Mhm. There is sampling of the.
Oh, I see. That's a huge difference. Is it? Let me see. For step in episode buffer. So the problem is when do you sample?
I think that's where it is sampled, right? Buffer transition.
Oh, I see. Right. So that's a difference. So you only
update.
right
Done.
you only sample when it's done, but you still updates you still sample the same number of episode lengths.
Yes.
But your performance of the DDPG is similar to mine, right?
I guess.
Because it
Which one?
just kind of oscillates. I remember you're showing me.
Yes.
Right. Okay. Then it shouldn't. I don't think it should matter that much. I did, however, put a restrictions on the CPU usage, so that might be the reason why it's slowing down. Um, the reasoning behind that it's kind of not very well explained, I suppose. So if you look at my batch file, um, I set up two environments. One is the number of threads that you could use, and I limit it to one. So that might be the reason why it's doing such a poor job. So what I'm gonna do actually is take off these two and see if it sort of makes a difference.
It is probably bound to. Usually, I use the full processor count to run the jobs. So.
Right. Of course. But of course, with the old server, I couldn't do that because that would effectively mean our server's cooling system is really bad. But now I have AWS, I don't have to worry about that anymore. So
All hell business.
now, why don't I just run this? Okay, I'll need to go to my weight and biases, delete the related experiments again. Okay, let me switch browser. Yeah, it's either crashed or failed. That's pretty funny. Oh, right. That's fine. Okay, I'm just gonna go run it. So this is without limits. Okay, so the job has been submitted. And by the way, do you want to see the AWS thing?
Well, what was it again? The free credits?
Yeah, well, not exactly free, but it's so much better than I guess what you pay.
Don't pay with the money? Is that it?
Huh?
Not free, but you don't pay with money?
Um, It's theoretically possible that it could be free, I suppose. Like you see this 5,000 credit. Amazing.
Okay, what's the catch?
So remember I was showing you on eBay?
Ah,
But it turns out this is what they do actually. They give you accounts at startup.com, and then they have this like startup benefits. And the first one is the 5,000 in AWS credits.
oh,
So, but
so
the membership to the website, so that's what the eBay seller was trying to get you into, which costs $300 officially. But I guess he has ways to sort of make it cheaper, I suppose.
mm,
But yeah, it's pretty good. And now I don't have to worry too much about the costs. I can, however, see my billings and, for example, go over here and see the elastic compute, and I can see that this past month for all of the experiments I run, it costs $20, and as you can see, it's been deducted by the credits. So that's pretty
okay,
cool.
okay.
Yeah. So overall, yeah, it's pretty good, I would say.
In total, how much did you have to pay to get those 5,000 credits?
I paid about $400.
Or
Right, but now that I think you can just sort of do this yourself, you because he actually didn't do too much, so I think you could have just gotten it for yourself, I
yeah,
suppose.
I'll check it out.
But I mean, yeah, yeah, feel free to. I'll probably share the account with you. Feel free to run experiments. Feel free to run experiments with that.
Okay, okay,
Yeah,
thanks.
yeah, no problem. Because it should last for quite a while.
I'm not so sure about that.
Yeah, well, we'll see.
We'll see. Okay.
Right. Okay. So other than that, what are something else to talk about? Right. There's something else that I want to talk about real quick, and I'm curious as to see how much of a performance gain would it produce. So in OpenAI and spinning up all those libraries, they do multi-processing to speed up the program. You can specify the number of CPUs you want to use.
Okay.
But
I guess.
beg your pardon?
But that's basically what you do when setting the MKL num threads variable,
No,
right?
no, it's totally different.
Difference.
Yeah, so even spinning up, it's different. Spinning up use this sort of MPI, multi-process interaction or whatever, to sort of spin up different instances. So what I do is you can specify the number of environments, and then it'll call this function called MPI fork. So it'll run the same file multiple times.
So it's basically parallelization,
Yes,
right?
parallelization. Yes, it's sort of running the same Python scripts, and then you're communicating with them somehow to do things. But I wonder if there's actually a need for that, because fundamentally, what if you just use the gem vector API? So, because if the bottleneck is your ability to run multiple environments, then it makes sense to run it in parallel. But as far as optimizations goes, um, right, let me actually see something real quick. Do they do the optimizations together? So what happens with their updates? So this is the PPO, right? Let me see.
Going down the rabbit hole.
Right, I think they use the parallelization just to generalize general data. They don't actually use the parallelization to do the compute. Like for example, over here, this will be the computation, right? But this is only getting the data. It's not using. So anything that is parallelized you can see there's like a MPI functions to associate with it. So there's an average for the Gauss divergence, average for the gradients, right?
So they do compute. Can you come back to the gradient averaging part?
Yeah,
Oh, yes, this one.
but that should be minimal because, like, let's take a look at what it does.
But if I'm not mistaken, this creates multiple agents in parallel. So
Yes, yes. So,
their networks should be also different.
yes, that is correct. That is correct. Is it?
Maybe it's a kind of like A3C applied to all the other algorithms, what they're doing,
Hmm.
asynchronously updating the network.
Is it though? Well, yeah. Anyway, I think that will be very interesting to dig into once we're done with DDPG and TD3. So, like for example, we could look into the paper A3C.
Mhm.
So A3C, they claim. So I was wondering, right? With the same number of time steps, does A3C actually perform better than A2C? So
But do we get the, when you say the same number of time steps, for example, if we run DDPG with one agent for 1 million, it means that we have to run, for example, the parallelized DDPG
mhm.
times 4, but each process only takes 250,000 steps. That's what we mean, right?
Right. Say that again. Sorry.
The simple DDPG
Uh
would
huh.
take 1 million steps with the same agent.
Yes.
But following the OpenAI version, they say the default CPU number, I mean the default parallel instance are 4, if I'm not mistaken. They use CPU 4 equals 4, right?
Right. Right.
Okay, so that it means that each like parallelized DDPG agent will do only 250,000 steps.
Sorry. 1 second. My Siri is telling me what parallelization is in the background. Anyway, right. So what the OpenAI baselines does is you specify the number of what's it called, the cores you want to
Total
use.
course.
Right, and then you specify the number of steps you want to run for each of the environment in the course. So let's say you have 3 environments and then you have 5 steps. Then the total number of batch size is 15, something like that, right?
Wait.
But anyway,
Okay,
so
let's
that's
yes.
that's sort of beyond the point that I was trying to make. So in the A3C paper, they say we do not use replay memory and rely on parallel actor employing different explorations, blah blah blah, to stabilize the training. That has been the case for the DQN with the experience replay. However, I don't think in the paper it's actually being proven, like comparing A3C with A2C with the same number of time steps. So if you see their comparison, it's always with comparing the training hours, which
That's
makes
quite
sense because it's training fast. But we have no idea whether within the same number of time steps it's actually performing similar or different. Does that make sense?
yes, I get your point. I get.
Yeah, and that's something that I want to look into, but we'll see. But yeah, so I think with the A3C, what they do is they sort of sync the policy, and then they when you actually run the experiments, sorry, when you actually step in the environments, you shouldn't be using different policies, right?
In A3C, I think you do so.
Well, because what you would do is you use. So let's say you have four workers, right? Each of those
Mhm.
workers use the same policy to step into the environment, creating their own experience, and they use those experience to generate different gradients. That's when it becomes different, and then they
Yes,
sort of average those gradients to update the master policy, I suppose.
yes,
Right. So in that case, they do synchronize at the end of every episode. And then after that, which means the same policy will be applied when stepping into each of those environments, right?
okay. That's
But I
so you
guess
say
but I guess if,
synchronize. They
go ahead.
sync all workers with the master, like the meta weights.
Hmm?
So at the beginning, maybe. I see, I see, I see.
Right, right.
So
But
most,
maybe it doesn't have to be exactly the same. Like with asynchronous methods, there's no reason for you to have to wait for the other worker to finish. I guess you
yes,
can synchronize it, but that's so if you have like I don't know 15 if you have 12 cores, then synchronizing the master policy, waiting all of the worker to finish is probably not going to make a difference. However, if you have I don't know, something like 100 CPUs running at the same time, then you probably don't want to wait other workers to finish, especially if you run experiments on games such as I don't know StarCraft 2, that some games could last significantly longer than the others.
yes. So you would not get the improvement that those workers have achieved
Yes.
until a while. That's
Yes, exactly.
well. I think we can always find a way to maybe synchronize it earlier, even though the learning is not done yet.
Yes, yes, of course. I think there are multiple different synchronization strategy. So my point is, if we want to sort of keep this simple, then maybe it doesn't have to be the case. If we
Yes,
do
actually,
if we do this sort of synchronization, maybe it doesn't have to be this complicated to implement. Like, so if we use something like the gym has a vectorized environments or something like that. So if we use this, then it'll basically sort of run different environments at the same time. And then if we just always use a master policy to sort of update them, then it's going to be roughly the same, right? You know what I mean?
yes, yes, yes.
But from the implementation standpoints, probably all we have to do is to use a synchronized vector environment, um, and then make some changes, and after that, it should be good, I guess. Actually, it wouldn't be exactly that simple, but my point is, if we don't have multiple different policies, it shouldn't be that difficult.
Okay, but this is so experimental.
Yeah, yeah, yeah. There's probably we shouldn't experiment with that at the current moment, but when we have a chance, because I am interested in solving long horizon problems, right? Like if you have this sort of game that lasts for I don't know 4,000, 5,000 time steps, then if you're using A2C, well, maybe not even 5,000. What if it ends? It's sort of like a continuous domain, you know, and then
Yes,
the episode finishes sort of. It's like after 2 million time steps, it finishes. Like, what are you supposed to do? You really shouldn't wait until the episode finished to do the optimizations, but rather you should learn as you proceed. So that's why I was looking at this sort of the stepping methods that the OpenAI's guys are doing, I suppose.
in your DDPG,
Yes.
maybe a little bit out of scope, but do you update every time step?
Beg your pardon?
Do you update the networks after every environment step?
Yes. There's a parameter to tune it though. So if we take a look at the code real quick. So this, sorry, not this one.
you have something like an update interval which waits a number of steps before updating.
Right, something like that. So initially, the global step has to greater than some sort of time step that the learning could even start. And after that, there's a training frequency that you can tune. So you can train the agents every 3 time steps, something like that.
I see.
The default one is, however, every time step though.
Okay.
Right. By the way, this is also the time to take a look at our hypothesis is correct, which I'll need to use a different. Um, did you see the screen that I'm?
Yep.
Do you see what I'm seeing?
1 dB.
Never mind. It's just some sort of flashing. I don't know if you were able to see it.
Oh yes, but maybe there was some flickering.
Yeah, every time I have to sort of close the browser and open a different one. All right, let's take a look. So we just ran a bunch of experiments. I'm really interested in knowing the CPU usage. So let's take a look at the Hopcheta, and show me. CPU is fine for now, but I really wonder if it's gonna have the significant drop that happens with. Let's
It
take
was
a
around 100K time steps.
exactly. Now where is the Hopcheta? Really? Oh, there it is. Right. Let's take a look real quick. See when did the CPU degrade. So this is after 2 hours. I guess we'll see soon enough if this is degrading. Before 2 hours, it's fine. It's like around 660% of the CPU utilization.
Does
But
it log the general usage of the CPU or the usage of your process specific?
I think it's the overall CPU usage. Wait, if that's the case, that might explain why it's
Yes.
performing like that. Because in the host server, if you're recording the CPU usage of the host server, then it's very possible that some of the experiments are finished and therefore the CPU usage of the host server drops significantly. But that's why you see the significant drop.
Yes. Because each process is basically using only one core, and when all the other cores free up, like the average is dragged down.
Mm-hmm. Right. That makes sense.
Maybe if you count the number of CPUs, you can actually find the proportional coefficient. Like assuming the smallest, you have like about 10% of CPU usage in the plot you're showing right now when it drops. So
I also wonder if we should do something like the frames per second metrics, like the FP.
frames,
Yeah, to sort of have a feeling of, but maybe for the debugging purpose of this program, just to see if the speed of the program drops significantly.
if it samples enough by every, okay, I see now.
Right, but
How many actual stimulation time steps per second?
yeah, exactly. But right now, there's no such metrics. Like it's very difficult to see. I suppose you can take the average overall, but you couldn't observe the global time steps per second, um, like over uh,
Or
at a
just
specific
global
time in
step?
at a specific time in day. I suppose.
I think you can do like if you pin the global step graph and you change the step to the relative time, you can get the.
Wait, what? Say it again.
Wait. Can you cancel it? Not this plot. Not this one. The global step in the charts, the third completely on the right. Yes, this one. And in the X one, you put the relative time or
That's
maybe wall time. So it will show you for every hours how many time steps are sampled.
that's interesting. What is the relative time?
Relative time is how long since you have started the process, the training.
Okay, I see. I see.
So in the first hour, I guess it's rising quite a lot of steps
Uh huh.
because probably the episodes are quite short.
But even if the episode is short, running longer episode, it could slow down the training, but it shouldn't slow down the number of steps that are being executed. Do you know what I mean?
Not much.
Let's actually. So I'm gonna save this and let's take a look at if any other experiments experience similar problems. I suppose. So that is actually an effective. What's it called? The frames per second, right? So there's no need for me to actually calculate it.
Yes.
Okay, that's pretty cool. Okay, let's take a look at PPO continuous actions. So with
I
the
think it's a little
PPO,
better.
yeah, it's constant, right?
Yes.
And I want to take a look at DQN, see if the similar things would happen. So not cart pole, but one of the more like lunar lander. DQN takes about a day. Let's take a look at global steps. Right, even with lunar lander, it's still the same. But how come with Hapchita, it's looking like that?
That's the DDPG, right?
Yeah, that's a DDPG. It doesn't make much. It doesn't make much sense. It seems.
Wait, did it just change?
Sorry. This is the one that I just started to run.
Oh,
Wait, so let me. Great. Uh, Let me see something real quick then. Oh man, did you see the blinking that I'm seeing?
yes, just a bit.
Yeah, I have to keep opening new browsers because of that. Okay, let me see the DDPG noise. And so the hopper ran for 5 days using the CPU, and the hopper using the GPU used 12 hours. I want to see its global step. I still don't quite understand the relative time, but that's okay.
Oh wait, did you
Oh, I see. What if I use a wall time? Something like that.
wall time? I think it will just show you the. Is that even possible in this case?
I guess not. Okay, so with the. So what is this? Right, this is the GPU. It actually speeds up in the end. What about this? Really? Yeah, I don't know. It doesn't show the significant slowing over here.
and the CPU usage is also about 10%.
I suppose, yeah.
Maybe it was just due to the fact that you run multiple processes at the same time,
Okay.
multi-threaded.
Right, right. Okay, never mind. I'll see what I can do with this, but this is probably as
So you said right now it bothered you that DDPG took what? Well, 10 hours, 1 day to train. Is that it?
yeah, it just takes a really long time to train, and for no apparent reasons.
Okay, I see. In my case, I use quite a lot of different servers with different specs, so it's something that actually occurs quite a lot. So
Okay, I see. I see.
maybe you don't have to mind it that much.
Right, right,
Or
right.
so to run some experiment on a dedicated server. I will try that later.
Okay,
It's
all
a
right.
way to experiment and see the training times.
I see. I see. Okay, well, that sounds good. Yeah, I'll take a look and see what we can do with it. But this is probably as far as we could do for now.
Could you show me the performance graph? I guess I can check it in my which not repository, which report sums up the DTPG results.
That's in the CleanRL benchmark
Okay,
repository.
so I'll just filter following the linear benchmark.
It should be the first one. Sorry, it should be like the cleanrl.costa.sh, something like that.
Okay, to but this has also other algorithms. There is only Walker 2D. Oh, yes.
There should be a
Let's
bunch.
see. Hop, hop. Ah, sweet soft actor critique. Now DDPG2 for some reason barely makes it out of the 500 score range.
Sorry, hold on one second. Where is the? Okay, there it is. Are you sharing your screen?
Yes,
Okay. So what is this?
it is a DD all your algorithm performance on Hopper Bullet app.
Yes.
Is this one still running or did it crash?
Oh, the DDPG that almost reached a million that crashed.
I see.
Right. But right now a new algorithm. Sorry, a new batch of experiments is running, and I don't know how long it's gonna take.
Amazon?
Hmm.
Amazon?
Yeah, yeah, yeah. AWS. Yeah.
Because I do not think the authors did the experiments on Pipelab, so there's no precise baseline I
Right.
can
Right.
compare.
Right. Okay.
Hop, hop.
But yeah. Anyway, we'll keep looking into this, but this is probably where we can do for now.
Okay.
All right.
Actually, I have some few more experiments I tried on DDPG.
Okay. Go ahead.
If you don't mind giving your input. So
Mm-hmm.
I think in the big, wait, I will bring up the algorithm quickly,
Mm-hmm. Yeah.
where they compute the targets. Where is this? I think it's here, right? Well, the action is
Actually, I couldn't
selecting.
see.
Okay.
You're right. Yeah. We're good.
Well, action selection with adding the noise for exploration.
Uh
This
huh.
is during the sample. Yes.
Right.
And during the update, the target is this yi. where the yi is used just sampling deterministically from the actor's policy,
Right.
so forth. So in the TD3 paper, they actually argue that in this case, it is better to sample also while adding some noise to the target to get a better estimate. I think they called it the target smoothing policy. And so I try to apply just that part to the DDPG itself with the one network. And well, here, for example, in blue, you have the version without the standard version.
Okay, Rasen, sorry, could you give me 1 second?
Oh, okay,
The Chrome is crashing. I'm gonna have to restart this real quick. Give me 1 second.
no problem.
Yeah, I was so right. I found it so weird that your screen wasn't moving at all. Anyway, go ahead. Now it should be good for at least a while.
Okay. So in blue, you have the version where the target mues are sampled deterministically, and the red one is with the noise added. And well, the general, this one is without the smoothing, so it's still quite well unstable. But you can see that the one with the target
It's
noise
better.
is actually better overall. Yes,
Right.
and it's better score. And this is just Hopper, but in other environments there is actually a similar trend.
Okay.
And this one is Walker 2D, not that hard yet. Half cheetah also is quite helpful to have it.
I see.
And well, and bullet does not change much, but I think it's well, since it does not do worse actually, it's quite good, I would say. And finally, in the humanoid, there is actually quite a nice improvement here in stability, at least.
Yeah, the stability looks really good.
How much is it? Just achieves a score of 5, but
I see.
yes, I found it quite interesting to.
Yeah, I think this will be definitely interesting to investigate when we look into the TD3 paper. Maybe we can do something like attributing the success of TD3.
maybe.
Yeah.
But I found it quite interesting anyway.
Yeah,
So
definitely.
the thing is, well, I think I talked about this paper maybe 2 weeks ago.
Yes.
And I finally got the courage to go through it. And basically, well, they argue for a better exploration method instead of using the, what was it? Well, this type of noise exploration method. They instead argue that where's the paper indeed? I think page 3. They can achieve a more structured exploration by perturbing the parameter noise themselves. There was quite a compelling argument here. I think this is the part here. Importantly, the perturb policy is sampled. Oh, no, not this part. Sorry. Yes, it's the state-dependent exploration. Right. So basically, if we use the simple normal noise, which we add to the action at the same time, for a same given state, if we sample multiple times, we get different noise. So the exploration is not consistent. And as a result, the data in the batch is also quite high variance, right? Right. But here, since we only add the noise to the parameters at the beginning of the episode, so for if the agency is the same state during the same epoch, the exploration becomes consistent. Intuitively, that's what they are saying in this paragraph. I think this line here. Therefore, even for a fixed state S, we will almost certainly obtain a different action whenever that state is handled again in the rollout. Since the action-based noise is completely independent. So yes, that's what I found actually quite interesting. In the paper.
Right. So they sort of make the exploration, stay dependent because. Right. If you're in, let's say, a state that you haven't previously visited before, then you should do more random exploration. But if you already sort of explored it all, maybe you shouldn't do too much exploration. Something like that.
Yes.
Okay.
So next, I tried the implementation,
Uh huh.
and here to keep it simple, I think the cyan color, cyan, right, is
Um,
the this one.
actually, right. They all look kind of similar.
Well, the clear blue. Let's keep it that way.
Okay.
The clear blue is the version with the most correct implementation I could manage to do
Okay.
of that paper. And as a baseline, I guess the more darker blue with a noise type is following a normal distribution
Uh huh.
and without a layer normalization. Okay. Well, layer norm is just a detail, but
Right.
in average overall, I guess in this case, right, the clear blue is actually the one with the best performance,
I see.
which we can't really see.
Yeah, you can't really see
But
there.
okay, let me maybe remove the useless one.
But
Okay,
but
looks
but
like
but right now, you after you do the smoothing, we can see it. That's fine.
that does. But I actually want to see without the add implementation here baseline against uh, parameter space noise. Uh,
I wouldn't read too much into. Maybe I wouldn't read too much into that part. Like this part, this graph, the smooth graph is pretty convincing. However, the one you were showing me before,
this one. Oh,
never mind. You're right. It's just hard to see, but the smooth version is much clearer.
but
That's
let's see.
interesting.
Okay.
So the
My,
so the so the parameterized exploration is better, I suppose,
mhm. Yes.
and they do run for a
Actually,
long time, even with the GPU, right?
yes. Every run is a GPU here. Well,
Okay,
here you can see that the takes 2 days,
right.
so don't mind it too much. Anyway, in other environments, actually,
Not
it's
so
not that
much.
helpful. Yes. So
Okay,
I don't know. I still have to run more experiments.
right. But yeah, I feel like there's maybe a critical bug with our DDPG implementation, or it maybe this is just the nature of DDPG because it's just too unstable. Again, as I sort of mentioned, let's go ahead for this week to go ahead and do the TD3 implementation and see
Well,
where we can push for it, and maybe we can go back to revisit DDPG and try to figure out what's wrong with it.
okay, sure. That could be a good learning experience.
Yeah, sounds good. All right. Is there something else you would like to add for this meeting?
Not me.
Okay. Well, thanks for the good discussion, and thanks for the meeting. And yeah. All right. See you next week.